Okay, geometry, section 3.8 in this textbook is a really long section because the authors decided to cram a ton of stuff in there rather than break it up. We're going to try to split this up into several sections and go slow with it. So the whole section is about slopes and equations of lines, and really in 3.8a, as we're calling it, we're just going to dive into this concept right here of slope. So this is definitely a topic you guys have seen before, but it might be one that you've forgotten a little about since you saw it. So when we talk about slope, we define that as being a numerical measurement of how steeply a line is either rising or falling. Couple key words to hit right there. Slope is numerical. We're not going to use words like say that a line is very steep or kind of steep, but we try to come up with a numerical system to measure how steep each one of these lines is. And the lines that we're going to be talking about are either going to be rising or falling, although there's two other possibilities we're going to explore here as well. So let's get into a few basics about slope right here, and I think you'll see all of these ideas illustrated a little bit more as we go through here. The main concept of slope is a quotient of two R words. You guys probably remember from Algebra 1. When we talk about the slope of a line, we discuss it as being in terms of its rise over its run to get from one point to another on a particular line. Now, we'll come back to that a little bit more in the future, but the actual formula for slope, this is probably the most important thing that we want to write down in this section of notes, is this formula right here. Y sub 2 minus Y sub 1 all over X sub 2 minus X sub 1. Now, if that notation looks familiar, we have used X and Y and 1 and 2 before when we were talking about the distance formula and the midpoint formula back in sections 1.4 and 1.7. So that's going to reference kind of the same thing. But that red box right there, guys, is the actual formula for slope that we're going to be using quite a bit later on in this section. Now, going just a little bit further right here, there's a notation that I want you guys to see because we consider geometry to be kind of a gateway course into higher levels of math. You might see this weird notation sometimes, a little triangle followed by a Y. Now that triangle is a Greek letter, everybody, kind of like pi, and it's the fourth letter in the Greek alphabet called delta. So we would read this now as delta y over delta x. And any time that you see delta being used in a math or a science class, it's used to represent the concept of change. So you might read this then as change in y over change in x. And the operation that we use to measure change in a quantity is subtraction. So that's kind of where that comes from. I would say that this last thing right here, the delta y over delta x, isn't something that you guys need to know right now. But when you do see it in the future, you can say, oh yeah, we saw that in geometry just a little bit. But as I said, guys, this formula right here is the key for finding slope. Now, as we dive into it a little bit more, there are only 4 different types of lines in terms of slope. So let's walk through the 4 kinds of lines. One of them is a line that looks like this. So you'll notice what I have here is a line that I've drawn that gets higher as we move from left to right. This is what we would call a rising line. And back on the last slide, we talked about slope being a measurement of how quickly a line might be rising. Now, it's a little bit misleading because if I just drew the line and I asked you, is it rising or falling, you really could make the argument that it's doing both. It's rising if you read it from left to right, but it's falling if you read it from right to left. Now that would be true, but lucky for us, we read a line in math the same way we read words on a page, which is from left to right. So this line rises as we move from left to right, and that's what we would call a rising line. Now, in terms of the slope of a rising line, let me switch to purple right here. And what we're going to do is talk about taking a little journey on this line here, guys, from one point that I'll call A to another point over here somewhere that I'm going to call point B. Now, obviously, this blue line gets from A to B diagonally, but when we're talking about slope, everything we're going to discuss is in terms of these words right here, rise over run. Rise refers to a vertical movement here, guys, that is normally going to go up, but could go down as well if your rise were a negative number. And run refers to a horizontal movement that would normally be right, but could be left if it were negative. So to get from A to B, what we would first do is rise. And in this case, we'd have to go up until we got to roughly this point right over here. And then we would take a sharp right turn. In fact, you'll notice that's a 90-degree right turn that we just took because we had a vertical line and a horizontal line. Those are perpendicular to each other. And now what we would say we have here, guys, is a positive rise, positive because we went up, followed by a positive run, because we went to the right, okay? So we went up on this line, and then we went to the right. And if your slope is rise over run, we just took a positive number divided by another positive number. And a positive divided by positive is going to tell you here, guys, that our slope of this line is going to be positive divided by positive is positive. So this is true, what we have written down here, guys. For every line that is rising from left to right, the slope of a rising line is always going to be positive. Now, I wouldn't put this in your notes if I was you guys, because this gets a little bit confusing, but if you went backwards from point B back to point A, your first move in this case would be to go down. That would actually be a negative rise, and then we would move back over to the left, which would be a negative run. And if you divided negative rise by negative run, well, a negative divided by a negative is still going to be positive. So it doesn't matter whether you're going from A to B or B to A, the slope of a rising line will be positive. Okay, the second type of line then, you could probably guess, would be one that is falling here from left to right. Now again, we always read lines from left to right. This is what we would call a falling line in that case. And if we wanted to talk about the slope of a falling line, well, let me do the same little journey here. I choose a point on the left somewhere, and I call that point A, and then a point somewhere on the right, and we'll call that one point B. Now, how do we get from A to B? It's always a vertical movement first, and in this case, from A to B, we'd have to go down to roughly right about there. Since we went down, that's a negative rise. Negative rise means we're actually going down, and then we would slide to the right to get to point B. And moving right is again a positive run. So when we went to talk about the slope right here, we would say that we have got ourselves a negative rise divided by a positive run. So rise over run will be negative over positive, and in this case, we would say that the slope of this line here is therefore going to be negative, because we're dividing a negative rise by a positive run. So again, this is another 100% true statement. Every line that is falling from left to right is going to have a slope that is negative. Okay, on to the other two types of lines, all right? We talked first about a line that's rising from left to right, then a line that's falling from left to right. A third possibility would be a line that isn't rising or falling, and instead is just kind of staying at exactly the same height as we move along here from left to right. So the word for this, guys, is that we now have a horizontal line. This one is not rising or falling, it's staying at the same height. So if we tried the same little trick before, we would choose some point over here on the left and call that A, and some point over here on the right and call that B. If I went to do rise and then run to get from A to B, you'll notice that there is no rise. Guys, we're not going up or down, so we have a rise of 0 and then a run from A to B that looks like it's going to be positive. Now, when we go to do rise over run this time, we're doing 0 divided by a positive number, and 0 divided by any number, whether it's positive or negative, is always going to equal 0 right on the nose. So every horizontal line has a slope of 0. All right, and we'll talk about a little trick to remember that here in just a second. Now, the fourth type of line, boy, if you focused on the red, you might be a little confused right here, because here we said slope is positive, then slope is negative, then slope is 0, and it might seem like those are the only three kinds of numbers that can exist. But if you focus on the blue, I think you know where we're going next. The one type of line we haven't talked about yet is one that doesn't move at all from left to right and instead just runs straight up and down. This is what we call a vertical line. Now, a lot of people misspell the end of this word. It's not C-L-E, it's C-A-L. That is a vertical line there, and if we were to find 2 points on that line here, doesn't really matter which one is which right here, so I'll call that A and I'll put B down here below it. If we tried to get from A to B, we're going to have a rise in this case, which is actually going to be negative the way that I've drawn it, although it could be positive, but there is no run to get from A to B. Okay, we're not going left or right at all. So when we go to do rise over run, we'd be taking a negative or a positive number divided by 0. And any number divided by 0 is going to give us something that is undefined. So, give me just a second, guys. Let me shrink this down a little bit, make that a little bit easier to get to. Okay, here we go. So in this case, everybody, we would say that this line right here has a slope that is, and here's an important word we need to know, undefined. Any number divided by 0 is undefined. Now, another thing we can say right here is that a vertical line has no slope. That's the same thing as saying that it's undefined, but undefined is probably the better way to go with it. Now, real quickly here, guys, it is really, really common that students are going to goof up these last two things that we talked about, horizontal and vertical lines. Lots of students make mistakes here, and they accidentally get the slope wrong. So, two quick little mnemonic devices I've always used to help me remember. A horizontal line has a slope of 0, and 0 looks like what letter? Looks like the letter O. The word horizontal has 2 O's in it, and you'll notice the word vertical doesn't have any at all. So the 0 slope goes with the word that has O's in it. That's horizontal. And then when we get over to vertical lines, I've always noticed that vertical begins with the letter V and undefined begins with the letter U. And U and V live right next to each other in the alphabet, and they also look really similar, guys. U just has a curve to it, whereas V is just straight lines, but they're pretty much the same general shape right there. So I can always remember then that the U and the V go together. So a vertical line has a slope that is undefined. Okay, guys, so if I were you, I would make sure that I've got this diagram drawn correctly in my notes. And I would say, well, let's study this and make sure we have this down before we take a quiz or a test. Every rising line has a positive slope. That's what happened right here. Every falling line has a negative slope. Every horizontal line has a slope of 0. And every vertical line has an undefined slope, or we would say no slope. So that's something we want to make sure that we have down. Okay, now on to kind of the bread and butter problems in this section right here. We're going to find the slope of the line passing through each pair of points. So here we've been given the points 5, -3 and -1, 0. And we're going to do this one according to big kid math, everybody. We are not going to graph this thing because graphs are time consuming and they take up space on your paper, and they're also sometimes misleading. But I will say that once we get our answer, I might draw a really quick rough sketch to make sure the answer makes sense. We are trying to find the slope here, so we're going to go back to the slope formula we wrote down on the first slide. M is equal to, it's the quotient of y2 minus y1 over x2 minus x1. And since it's our first problem here, it might be a good idea, guys, to label the 4 numbers up above. 5 is our first x-coordinate, so that's x1. -3 is our first y-coordinate, so that's y1. -1 is the second x-coordinate, that's x2. And 0 is the second y-coordinate, that's y2. So now we've written the formula. Let's just fill in what we know. The y2 here we said was 0, and then minus y1, which is -3. Now the formula says minus, so I definitely think subtraction, but we're subtracting a -3. So rather than writing minus -3, we know that minus -3 is just going to become a +3. Down on the bottom, x2, the second x-coordinate is -1, minus, because that's what the formula says, and then x1 is 5. Now you could go to your calculator right now and type all of this in and it would get you the answer here, guys, but I don't think this one is too tough to do by hand. In the numerator, 0 plus 3 is 3, and in the denominator, -1 minus 5 is -6. Two things. If you want to get full credit on a slope problem, guys, you've got to simplify your fractions. 3 over -6, let me ignore the negative right now, we can divide a 3 out from all of those and get a 1 on top, that's 3 divided by 3, and on bottom, 6 divided by 3 would get us a 2. Now, in terms of the sign, right here, we just took a positive divided by a negative, which is going to get us a negative result. And guys, there are 3 places that you could put that negative sign. You could put it right out in front of the fraction like this, or you could put it in the denominator of the fraction like that, or you can do what I always recommend, which is always, always, always to put that negative in the numerator. Now, the reason I say to always put it there is it's easiest, I think, to understand that our rise is negative, but our run is positive when you see that negative up on top. So our answer here, let me go ahead and write over that in blue, is -1/2. Now, this is not going to prove anything, guys, although it could potentially prove if we had done something wrong. I'm going to draw a really quick rough graph and see if this answer makes some sense. Our first point was at 5, -3, which means that to locate it, I start at the origin, right in the middle, and I go 5 units to the right, and then 3 units down, which is going to get me roughly down here somewhere into the 4th quadrant. You'll notice, guys, I'm not using a real grid here. I'm not counting things off. I just want it to be close. The second ordered pair, -1, 0. So for that, we start at the origin, we go 1 unit left, and then we don't move up or down at all. So that point is going to be located right about here, and that's -1, 0. And now, there's only one line that passes through both of those 2 points, and it would look something like this. Now, the first thing I would ask you guys is that line rising or falling or horizontal or vertical as we read it from left to right? And the answer to that is that this line is falling. And so, if we go back to this last slide we talked about right here, every line that's falling from left to right has to have a negative slope. So that means, oops, sorry guys, that our slope right here should be negative because the line is falling, and sure enough, we came up with a negative slope. Now that doesn't guarantee that we got the whole problem right, but if we had gotten a positive slope, or 0 or undefined, that would guarantee that we got the problem wrong. Okay? In essence, guys, what's happening is to get from point A to point B, this version of the slope, before we simplified it, is our rise and run. Okay? Actually, with 3 over -6, I probably would have done it differently. From A to B, I would have gone down 3 units and then 6 to the right. So a rise of -3 and a run of 6, that's the same thing as this. But when we simplified it then, to go to a slope of -1/2, what that really means is we took some baby steps. From point A, we went down 1, right 2, down 1, right 2, and one more time, down 1, right 2, and that eventually got us to point B. The reason it took me 3 steps is because that is what we divided both the top and the bottom by when we tried to simplify that fraction, and that number there is the number of baby steps it took to get from point A to point B. Okay, so I feel pretty good about this answer right here. Let's try another one here, guys. And I would really advise you, if you are watching this, to maybe pause the video, try this problem on your own, then hit play and see if you got the right answer. Okay, so we're going to use our same formula for slope now. M is y2 minus y1 over x2 minus x1. So in this problem, here we go. Our second y coordinate is 3 minus our first y coordinate, which is -9. So the minus -9 becomes a plus. And then down on the bottom, we've got an x2. Our second x value is 4 minus x1, our first x value is -4. So again, the minus negative becomes a plus. The 3 plus 9 is 12. The 4 plus 4 is 8. And now we can divide a 4 out from both of those numbers. 12 divided by 4 is 3. 8 divided by 4 is 2. Guys, we always express slope as a fraction, even an improper fraction if that's what it is, so this is our answer right here. We would never write the slope, even though it's mathematically true, as a decimal, which would be 1.5, or we never make it a mixed number like 1.5. Both of these things are technically correct, but when we're dealing with slope, it really helps us to have it written as a simple fraction of one number over another number, so we can think about it in terms of rise and run. And again, guys, just a really quick graph to verify this answer. -4, -9 means we go left 4 and then down 9 units. So that's roughly here somewhere in the third quadrant. And then 4, 3 means 4 units to the right, 3 units up. So 4, 3 would be roughly there. We would draw the one and only line that passes through those 2 points, and we see that this line is rising, which means that our slope should be positive. And sure enough, we came up with a positive slope. So to get from point A to point B, I've got a big rise followed by a big run right here. And again, these two numbers actually tell you here, our rise was 12 and our run here was equal to 8. So the rise of 12 over the run of 8, that gets us from point A to point B. But if we wanted baby steps, I'd be following this slope right here. Up 3, right 2. Up 3, right 2, up 3, right 2, up 3, right 2. What did we divide 12 by to get 3? 4. And the same thing with going from 8 to 2. So that's why there's going to be 4 baby steps along the way here to get from -4, -9 to 4, 3. Okay, 2 more examples, guys, and these 2 I would definitely say are special cases, so let's talk about this. Now, you might notice something interesting about these 2 ordered pairs before we even get started, and if you do, good for you. If not, oh well, let's just treat this like we did the last 2 problems. No reason to think it should be anything different. So here we go, guys. Our formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So let's fill in what we know. y2 is 3, this 3, minus y1, which is also 3. Down on the bottom, x2 is going to be 4, and then minus -7, so that becomes plus 7. And maybe now you see what's about to happen. Our numerator becomes 0, our denominator is 11. And I want to be careful about the way I say this. 0 divided by any non-zero number is always equal to 0. This is just one of those concepts that people tend to struggle with kind of a lot. So if you're ever not sure, just ask your calculator, hey, what is 0 divided by 11 in this case? And sure enough, it tells you that the answer is 0. Okay, so 0 over 11 means that our slope is 0. And if I want to answer the question, find the slope of the line here, we are done, guys. This is our answer, and our slope is 0. But if we go back, 3 slides right here, and we look again, what we should realize now is that we are dealing with this case right over here. A slope of 0 means that our line is horizontal. So maybe we could just do another quick graph here and see, there we go, if this makes sense. Okay, the point -7, 3 means we're going left 7 units and then up 3. So I'm right about here somewhere at -7, 3. And my second point, 4, 3, means we're going 4 units to the right and 3 units up. So here is 4, 3. And when we go to draw the only line that passes through those 2 points, sure enough, guys, we see that this line is horizontal. And that means that the slope of a horizontal line, wait a minute, because horizontal has O's in it, the slope of that horizontal line should be 0, which is exactly what we found here. So the thing you might have noticed at the very beginning of this problem, unlike the last 2, those 2 y-coordinates were exactly the same number. And when that happened, we ended up with a slope of 0, which meant that our line was horizontal. And if you're clever, guys, I bet you know where we're going here. The last example I have for you looks like this. And again, maybe you notice something here. But if not, let's dive into it. Slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Here we go. Y sub 2, the second y coordinate is negative 2, minus y1, that first y coordinate is 3. Down on the bottom, x sub 2, the second x is negative 7, minus x sub 1, which is also negative 7. So minus negative 7 becomes plus. So what does that do for us, guys? Negative 2 minus 3 is negative 5, but I really don't care much about that numerator because I got bigger problems in my denominator. Negative 7 plus 7 is 0, and any number divided by 0, let's see what this calculator says, guys. I think we had a 5 there. Divided by 0 tells me that it is undefined. So this is just one of those basic ideas that high school math people get wrong all the time, guys. If we take a look right here, 0 divided by any non-zero number, that always equals 0. But a number divided by 0, that is going to be undefined. So you might want to put a little star by these last two examples in your notes and say, hey, this is something we ought to be able to study and know. Now, I think you guys know what's going to happen when I do a quick graph. Negative 7, 3 means left 7, up 3. So we're right about here, negative 7, 3, followed by negative 7, negative 2, which would be left 7 and then down 2. The only line that connects those 2 points is one that looks like this, which is a vertical line. All right, and going way back to what we wrote on the second slide here, the slope of every vertical line is going to be undefined. Now, just to review our little mnemonic devices here, looking at these last two problems, guys, horizontal has O's in it, so the slope is 0, which looks like an O. Vertical begins with the letter V. Undefined begins with the letter U. So those last two examples, guys, are kind of two of the special cases. So this is example D and this one C. So I wanted to show you what a horizontal and vertical line look like when you find their slopes, but I would say that example B and example A before those are kind of the more typical problems. All right, guys, that's everything we have for you right here in 3.8a. Let's dive into that homework, get a little bit of practice with slope, and see how it goes. Good luck, everybody.